Happy Friday, security gang. Welcome to another episode of the CyberHub podcast. We've got a very, very special one for all of y'all today, in case you missed all the hype all week. Steve Orrin. Steve, welcome to the show, buddy.
Thank you, James. It's a pleasure to be here today.
It's great to have you. For those who don't know who Steve is, have been living under a rock potentially. Steve is the federal CTO over at Intel, one of my favorite companies, and senior principal engineer. I know most people love NVIDIA, but I've been an Intel guy my whole life pretty much. So why change now? I stick to my horses here. But for those who don't know Steve, previously Steve was the CSO over at Sarvega and Sanctum. Before joining Intel, he was the CSO and CTO at both respectively, and then the CTO and co-founder of Lockstar and CTO over at Sin Data. He's also a guest researcher at the NIST National Cybersecurity Center of Excellence, the NCCOE, and is a fellow at the Center for Advanced Defense Studies and the chair of the INSA Cyber Committee, all of which are really, really important roles. So, Steve, do you have a life outside of cyber and semiconductors?
I do. I have a family and small kids, and they keep me quite busy when I'm not working.
Yeah, which is a balance. But today's show is not about Steve's personal life. I promise you that, everyone. We're really talking about kind of Steve has a very interesting view on AI, and I think it's a very valid view that many practitioners we fall into the what's AI and how people use and look at AI. And Steve is we were preparing to do the show. You had a few really good inputs on AI. So looking at artificial intelligence, how do you see it? What's your kind of big philosophy around how AI is going to change?
So, James, it's interesting when you bring up AI because you can't, throw a rock and not hit something that has AI in the title today. It is literally everywhere. It is the hype. And it's one of those things that we're not seeing the end of the hype curve. Because every time you sort of get your feel on one area of AI, something new comes out and everyone's talking about that next wave. And so it keeps feeding on itself. But when we get past the hype and we start looking, okay, how do I practically implement AI? How do I use this as a tool? The challenge that we've run into is a lot of executives, a lot of leaders, a lot of practitioners think that they can just sort of sprinkle some AI pixie dust on any problem space and magic, I can solve any problem. And that approach is leading to a lot of failures and a lot of fits and starts in the practical implementation of AI because AI can't do everything. It can't solve every problem. And oftentimes organizations make the mistake of thinking, well, I can put AI and it will just take care of the problem space I'm dealing with. When you look at the cyber domain, everyone is really concerned about that, that 10% APT that we've never seen before, that new nation state actor, that next generation of ransomware. And so, well, if that's a problem, AI should solve it. And that is the absolute wrong approach. AI is good as a tool to tackle the kind of problems where we have a lot of data and representation of the problem. It's really good at tackling manual, non-automated, human in the loop kind of processes that are repeated. And it is very good at looking at and finding similarities and correlations between those areas, assuming you have the data sets. And so when people really start thinking about the practical ways to implement AI, where they should be focusing on is some of those major challenges that aren't the exquisite, but are the more mundane. And I think one of the greatest examples of that in the cyber domain is not, like I said, going after the really hard problems that you want to bring your top tier talent and try to replace them, but rather it's really about how do I automate what I call the 80% of the stupid stuff, the everyday firefighting, the vulnerability patch management, the every hit on the firewall, every ping on my SIM, all of the normal day-to-day rote, repeated activities that IT security and Infosec have to be challenged with on a regular basis is actually the ripe place for applying some machine learning and AI tools. And again, it's not about replacing your IT staff with an AI. It's really about enabling them to focus on the really hard problems and letting the AI and the automation that it will bring deal with the more mundane, everyday firefighting that is really taxing and taking up most of their time. And here's the good news. We have lots of data inside our organizations and collectively in the industry about those mundane processes, about those day-to-day firefights, about the kinds of signals that show up on our SIM and our dashboard. And so AI takes data to train. It is data hungry. And so we can feed it those existing records, those logs, those past events and correlations, feed them into the system, and allow it to train on those so that can then automate those processes or identify those risks and mitigate them, or at least identify them and highlight their priority much quicker than that team of people who are sitting there constantly firefighting. Whereas the exquisite or the new nation state actor, the very new kind of APT or the next major risk that we haven't really documented well, we don't have the data on what that is or how it works. We have one example. Okay, it hit this one company, so we have one set of TTPs. So it is not a good use case of AI because AI needs the data in order to be operational and to give you good results. So I think one of the things I like to say is we need to flip it on its head as far as where to apply these AI tools and apply them not to the biggest challenge that we're faced with from a perception perspective, but actually at the challenges that we seem to know how to do, but they're time consuming, costly, and inefficient today. Because where you look at it across any industry, cyber, financial services, logistics, supply chain, the biggest successes in AI deployments have really been at attacking those more manual, mundane, known problems and getting better efficiencies in them versus trying to solve some next generation problem we haven't really figured out yet. And so to say, my view on AI is a little different. It's where do we actually get success in employing AI as a tool or as an asset versus trying to solve every possible problem, which is where a lot of the hype curve happens to be.
So you brought up a lot in what you just said, and we're gonna break it down for everyone in the audience and everyone commenting, watching, and listening right now is the following. One, you kind of brought up the have AI do 80% of the mundane stuff. And that takes me to I'm a history buff. I don't know if you knew that or not, Steve. I love history books behind me. Many I don't read fiction. I read nonfiction, right? Like I know some people love, fiction books and Harry Potter. I don't. Never got into Harry Potter, never got into any of the fiction stuff. I enjoy very much nonfiction. So this takes me back 100 years to the Industrial Revolution, right? And robotics, the early stages of robotics and kind of the replacement of humans on specific assembly line work that everyone said that was going to be horrible and it's going to destroy, and it didn't. It ended up letting humans go away from nailing stuff onto a board to focusing on solving really critical problems, which is what I believe AI is also going to do for us now, except back then this was labor work and now we're on the computer side of it. So I think like we felt like we've advanced, right? We've gone from hard physical labor to computers and as such, and so history tends to repeat itself, and I agree with you. There's a switch that needs to be done, but the problem is the switch in the human mind today, and I say this lightly, so please, everyone listening, don't take offense, but if you've tuned into the show before, um, we've lost our ability to critically think as humans. And because of smartphones from 2007 and onward, really, I mean, you could go back to 2000, right? The first Palm Pilot, right? Everyone remembers Palm One, um, right? Kind of starting to lose your ability to critically think and start to get commands and start to get answers rather than research, rather than look at it. But AI right now requires us to go back to that kind of infinite, I think, part of our DNA, which is innovate to kind of take that. Now, you talked about the 80% problem, Steve. You talked about automating a lot of things, not only in cyber, but in general, right? Like, to me, I see AI reducing risk. What do you kind of see if we look outside of cyber, right? Cyber is just one aspect of business. And I like to think our Friday conversations are really more than just cyber, they're business. Where do you see AI coming in to help you as a CTO, kind of your day-to-day work? What use cases or how do you explore AI in terms of really enhancing operations as a principal security, as a principal, engineer at Intel?
So you bring up some really good examples. And let's talk about some of those other industry, other domains where AI is already having effect, or we're seeing on the cusp of where it's going to have massive impact on efficiency and quality. One is and I'll pick on the mundane again, manual paper-based processes. So think contract management, compliance management, and I'm not talking about security compliance. I'm talking like regulatory compliance. Even when you're building stuff for a particular vertical industry like critical infrastructure or healthcare, there's a 500-page document that says that your widget has to do all these things. some of the more mundane parts of that aren't the cool technology you're deploying, but it's, did you document these 16 different ways that your product operates? Did you use certified bolts and locking together your system? Do you have water seals? And like all that kind of compliance work that people are documenting into checklists and then checking against the document and then ultimately reporting can be totally automated with an AI tool that can scan through the reports, has been trained on the regulations, and at a minimum, the first step, just identify abnormalities or anomalies in the reporting. That alone can save your engineering time significantly, because instead of having humans have to read through these and check them for validity, you have an automated tool that is looking for non-conformance. And then the 10% of left in the document that didn't match, someone can go track down. But it gets better, because as these systems become more tuned to what are the variances that you find, you can actually reduce those even more so. And so things like mundane processes, paper-based processes are really good applications for applying AI. And we see this across multiple industries. The government is using AI today to find redundancy or inconsistencies in contract terms across thousands upon thousands of paper-based contracts. It's automating the process of shipbuilding. So, we think of shipbuilding, well, you're welding steel, you're putting systems in place, but there's actually a lot of paperwork in the supply chain that has to happen for every vendor to submit their proposals and do they conform to the standards? Have they bought the right tools, and are they using those tools in the proper way? All that process takes time, takes money, takes people. And if I can reduce that, I can actually have a substantive impact on the delivery of a ship or the delivery of a vehicle by reducing the paperwork time. The same thing we're seeing in supply chain logistics, being able to automate and analyze resiliency in our supply chains, identify areas that, whether it be geopolitical or weather-based disruptions, and having already pre-planned more efficient routes, or having alternates that achieve your end goal of delivering your goods to certain places, or having your fleet ready and fueled to be able to pick up the goods. All those kind of mundane processes are ripe for AI innovation, and we're seeing it being deployed across multiple industries. We're seeing it being used in development, and this is one of the things. It's a touchy subject for developers. A lot of developers, when ChatGPT and these other things came out, said, "Oh my gosh, AI is going to replace me." And then they started looking at it, and they said, "Well, the code that's producing is pretty crap, so maybe that's not going to replace me just yet." But here's where the real power is. If I train the AI on the entire knowledge base and my source code and my documentation specs, I can enable my developers to then use like a localized GPT kind of chat bot to identify modules that may be good to reuse, or ones that are broken that I shouldn't be using and incorporating. They can actually get better information instead of doing the manual search and the trial and error. It can automate the development process, not by replacing them, but actually having them get quicker time to the information they need to be able to do their job, which is the inventive part of coding that application or building that firmware or deploying that new solution stack. And one of the nice things about AI is that it can be trained across multiple domains. So you have an engineer that's really, he's a Python expert. And you have another engineer, and she is an expert in firmware. And you have to get them together to actually build a system that will coordinate. Imagine if you could give them both access to a tool that's cross-trained, that knows the environments, knows the specs, knows all the code samples across those different domains. And now they can interactively work with that automation tool to augment them. It actually can help them speed their problem solving and their time to delivery of a better quality product, without the errors that normally, like all they compile and trying to track down, though, that was a firmware problem, or that was a software problem, that was a Kubernetes problem. So one of the things we're seeing is that it's a really cool tool to augment the developers, not replace them, to enhance their ability to quickly identify what could be a potential problem, or what is the right module or the right code sample to leverage in order to build out the application functionality. So these kind of AI tools, and that's really the key thing to think about, is it's a tool, it's a hammer, it's a screwdriver, it's a tool in our kit that makes us more efficient at the jobs we're trying to do.
Yeah, it's the automation tool. It's that tool that kind of speeds things up for you, right? Um,
Exactly.
and helps create a better efficiency and better productivity, and lets humans really do what humans do best. We live in the best time ever in human history, right? Everything's at your fingertip. Everything's within. No one worries. It used to be that if you wanted to cross country on a horse and carriage, there's a very good chance you never made it across the country, right? There are a lot of risks involved with that. Today, you want to get across the country, you hop on an airplane, and you're there in a few hours. And we take that for granted, but go back 100 years and tell someone on a horse and carriage, before cars, hey, you're going to cross country and it's going to be done in 3 hours. They'd look at you and be like, shut up. What are you talking about? That's never going to happen, right? How are you going to get a horse to go that fast? And you're like, no, we're going to fly. And they'd be like, okay, you're crazy. You should be taken out back and shot. Um, and AI is just that for us, right? It's supposed to speed up things. It's supposed to really kind of bring it. I like the idea of what you just kind of talked about in specific use cases, where you're kind of building that collaboration between Python, Rust, C++, especially on the dev side, right? The other thing I see AI, and I don't know what your view is on this, is kind of AI bridging the gap in some of the more challenging parts of the business. So here's a lot of data set, like you said, and in a development, in a company like Intel or the federal government or anywhere, right? Companies that have been around for decades. You've got a lot of data, and a lot of that data has been digitized. But if you can feed it to AI and then say, here's a current process, here's all the historical data, find me a good way to reduce a process that takes me 4 months to 1 month.
or faster. And that's one of the cool
Right,
things we're seeing is it goes from months to minutes in some cases,
right.
just because of the latencies built into to manual people-based systems.
W-
And it also shows efficiencies that people have biases. It's inherent, and that's how you were taught to do something. That's how they were taught to do something. Everyone else seems to be doing it, so that must be the right way. And while there's definitely biases that can be introduced in AI, and we're not talking about that, but in general, when you train AI across different domains and across multiple data sets, it's going to see opportunities for efficiencies that are non-obvious to folks that are sort of steeped in a particular way of doing things, whether that be layout of systems, the building of a factory, uh, the logistics around delivering trucks to locations based on, well, this is the most, this must be the fastest way because there's the highway and that must be the best way to get a truck from point A to point B. The AI is seeing things very differently. And I think one of the really good examples of just sort of that efficiency of the scale has been in the medical sciences. And there's a lot of controversy around this, but the reports and the studies that we're seeing, in the case of, let's say, cancer detection from various different radio scans, is, there could be a doctor that's got 40 years experience and he is or she is really good at identifying early stage cancer for the kind of cancers that they've seen all throughout their lives. And there are tens of thousands of those doctors that have that kind of skill. Individually, they're really good at their job. If you train AI on all of their past predictions, so you get all the scans and they're, yes, that's cancer in that little cell right there, and you train it, now you have a tool that is basically the collective of those multiple thousands of really smart people that I can hand to not just a beginning oncologist early in their career, but even to a senior oncologist. And it gives them the ability to more quickly identify cancer and earlier in its life cycle than individually, because again, they only know what they've seen. And the AI has the ability to see across multiple people. So people who've seen something interesting in Africa, the person in America may not have ever seen a cancer that looked like that. But by having the collective, we actually enable, we float all boats together. All oncologists get better at identifying cancer earlier because of the augmentation of AI. And we see this kind of trend in many cases because, while I'm not saying the AI is going to replace the oncologist, but it's going to get the collective knowledge of that domain as an asset in their hands without having to read 40,000 scans of every other doctor that's ever existed. And that is the power of the training on these kind of data sets. Part of the problem we see today is that everyone is sort of looking at these sort of massively trained LLMs that are just trained on everything. And really, the big bang for the buck and where you're getting the really good results is actually on the domain specific side of the AI, where it's less about training on every possible piece of data on the internet, but focus training on the domain specific knowledge. Like I said, like oncology scans, or on supply chain documents, or on sort of the fault tolerance of certain metals. When you get those kind of specific AI training, you really get amazing results because you've constricted the domain of which you're applying that AI. So there's less likely for interference or other biases to be introduced outside of the domain you're focused on.
Right. So to me, when I've heard you say bias a few times, and I'm sure our listeners and so forth, and we've obviously seen the existing challenges with some of the models in terms of biases and whatnot. I mean, something's only as smart as the person programming it and kind of training it,
And the
right?
data
So
that they use,
and
yes.
the data that they use, and those are, I'd like to say that um, um, I think that's the bigger challenge around AI than the actual use cases, right? It kind of goes down to the conversation of, well, how what data is it using, and what level is it being trained to view that data, and from from what perspective. Go to any chat gpt and give it a command, to be a prompt engineer for a minute, right, and say, I've taken a paper, I've written an article I wrote, and I said, rewrite this article so a second grader can understand it, and it did that wonderfully, right. um but you know it was trained to present it to a second grader.
Yeah.
Right. So how do you push back on the biases conversation in terms of training AI?
So, James, you hit on a really important point, and this goes to the fundamentals of what a lot of people are talking about when we talk about security and ethical use and reliability of these AI systems, and that is visibility or transparency, depending on what side of the coin you're looking on. Having the ability to verify what data sets trained that AI, what data was used, whether it was real data, synthetic data, but understanding the data sets, understanding the tuning and optimization that was performed on those data sets and on that model, and then understanding how the model is being used are absolutely critical to that point of how do I trust this AI is giving me accurate results. And one of the things to keep in mind is it's actually have to happen on both sides. So when you start building your AI, you need to know what data am I using and document that. Because oftentimes the one who's building the initials or doing the initial data curation may not know every use case that that model will end up being used for. And that's where we see the real problem. A great example, and again, I'll pick back on the medical industry. There's been a couple of reports on this. One of the first AIs that we use for medical diagnoses, it was giving really wrong information for a large swath of the population. And when they did the analysis, what they found is that the data sets were very limited, even though they had lots of data. And here was the heart of the problem. Many of the universities that had initially created those data sets had done it as sort of, open to the community of college students to sign up and get scanned, sign up and provide blood tests and things. And what they found is the vast majority, so a large amount of the data, I mean, we're talking 85 or more percent, were white males between the ages of 18 and 25. Well, think about the population of a US college and of who's got time on their hands and who decided that they didn't care about getting scanned. It happened to be 18 to 25-year-old white males, which is great if you're only doing analysis and inferencing against white males who are 18 to 25. The problem is that the model was being used to diagnose, African Americans, females, older people, younger people, and that's the problem. The data that it was trained on was not correlated to what the problem they were trying to solve. They were trying to do diagnosis of people, not of just a small subset. And so that's why understanding the problem you're trying to solve with the AI is critical to understand in the early stages of the data sourcing, and then providing transparency so that when someone says, "Hey, I want to use this model elsewhere," I know that, hey, it wasn't trained on the population that may be part of my end result. So I need to retrain or add to or do spot training and adaptation training to augment the model with data sets that are relevant to the domain that I'm focused on. And that's where a lot of the current research and activity is on this sort of late stage model training to be able to get it specific to the domain or to be able to generalize what was a specific set of data to a larger audience by, again, incorporating that diversity of data. But where every time we've seen the AI guys go horribly wrong, oftentimes it's because the data was too narrow or too like in its data set. We trained it on 1 million cats and are surprised when it can't identify a plane. Well, duh. And so it's
Right.
that it's understanding the life cycle and having the right stakeholders involved from the get-go that will produce those more accurate results on the other side. And when I talk about bias, it's not always, bad. It's not like evil bias. It's just inherent bias in the data set drives bias into the inference and
Well,
into the model.
and I want to clarify that because because when we talk about bias, it's not the bias everyone kind of automatically defaults to in today's environment. It's rather the bias of, like you said, the data sets, and it's the bias behind how you train a model. And I think that's why the open AI, or the Google version of AI, and many other versions of AI, I think all of those kind of open source, very public models are eventually going to die off to the more vertical specific type models, right? And I think you're going to see that in healthcare. I think there's a huge benefit for all insurance providers in this country to unite data sets and go, all right, understanding preventative medicine. We know that treating cancer could cost X amount of dollars. Understanding that if we prevent it early, we can save more lives, etc. And we want to do the right thing because that's the right thing to do. You could essentially look at that and go, let's unite the data, let's build a model that really could be, industry standard in terms of, diagnosing serious disease early on, right? As a general kind of way to look at it. Or even if we're doing the right testing, if you take a whole bunch of different testing methods and you go, all right, let's take all of these different testing methods, and it's a lot of data and it's a lot of research, and put it all in one. I mean, the medical use cases you've given hit home for me, because I'm a big advocate of good medicine and good science. And I think, there's no way humans can even look at how to take that data. And I mean, if you've ever tried to analyze petabytes worth of data, it's impossible.
Yeah. And
It's
James,
impossible.
yeah, and I think the other thing to note that is it's not just good for humanity, which it is, it's also good for business. Because if you diagnose early and you can prevent it, then it's much, the companies actually benefit well. So it's a dual benefit to organizations like insurance providers and healthcare providers, because the earlier you catch something, the cheaper long term it is to actually to prevent or to diagnose and provide the right
And right, and
medicines
identify the
and
right
course of
treatment.
action.
Right. And when we look at this from a technology perspective, folks, I think this is where it really kind of AI in that brainstorming sessions, in the different use cases within a company. You've got to understand what your business is. You've got to understand what data models and what's the problem you're trying to solve for. You said that, I think, 5 times. I counted on my hands, Steve. Like, what are you trying to solve for using AI? And like you said early on, if you're trying to solve for that one time APT, I reported on something last week. It's called the cluster bomb. It's the cyber version of cluster bombs, right? So it's a threat actor that drops 7 to 10 different types of malwares and information stealers at one point on a device, right?
Yeah.
Just a cluster bomb of sorts. And I go, all right, AI is never going to be able to recognize that because it doesn't have the data set. Because all data sets of all AI, talk to any MDR, XDR, EDR, you name it,
Yeah.
whatever you want, they're recognized to identify one type of malware or one type of information stealer. It's not trained to identify 10. So when you drop 10, it may just break. Just
And
saying.
yeah,
There's a
and more importantly, even if it detects the individual, it's going to think those are individual infections and treat them as such and miss the actual root cause, which was a single delivery vehicle that delivered all those and maybe doing other things. And that's the thing, it doesn't have the context for these more complex, um, well thought out attacks. It's very, I can detect this kind of abnormal behavior because I've seen it 14 million times before. New behaviors are really hard. And one of the interesting things about some of the even the more modern generative AI, the prediction models, which are really powerful, they're good at predicting sort of the next several steps, but not the or inorganic leaps until it's seen enough of those inorganic leaps to create that similarity model for it. And so I think that's one of the things that, again, separating what what you have good data for versus the one-off things that you're never going to find just with an AI alone. And sort of separating those two. And it goes back to what you say I've said 5 times, but it's really the heart of it. Asking the right question. What is it you want to try to solve? And the follow-up question is, do I have the data to help drive that model? And those two things have to be the first part of your conversation before you go build the AI or do any data sourcing is A, what am I trying to do? And B, do I have or can I get access to the data that will help drive that AI model? Because you could be trying to solve a really important problem, but if there's no data, then you're never going to be successful. And just saying, well, we'll build synthetic data, it's going to be very limited in your practical application.
And synthetic data, by the way, is not real data. And I just want to make that very, very crystal clear. Synthetic data is like synthetic beef. It may look the same, it may try to taste the same, but it doesn't have the same nutritional value, nor nor does it. I don't care what you say. Synthetic beef does not taste like real beef. Just saying.
Yeah.
Uh,
But synthetic data has its use. It has its use
it
to
has some
augment.
use cases, but it's
Yeah.
not the use case by which you can build a way to solve a problem. You can complement.
Right.
You got to have a data set. You've got to have a real data set, and then you can say, "All right, I want to feed it synthetic data to see what it does in if action X happened here." And I don't have this action X, but I want to do it. Like what we just talked about, the malware bomb.
Yeah.
Like that's a way to do that, right? But it doesn't always mean that.
Exactly.
Like you've got to be mindful of those things. I'll say that. Now we're almost at time, Steve, so I want to be really mindful of that. Um, what's one, if you could share, kind of, you've shared a lot of wisdom in the last 30 minutes, so I'm sure you got a whole lot more, but what's one thing you would tell anyone listening or watching around AI? What's kind of like your best practices around how do you adopt AI responsibly, ethically, and kind of how do you evangelize it within your organization to get people to think properly in terms of how to use and operate AI?
So, James, I think there are three things that I recommend, and they're all part of sort of a long-going sort of life cycle approach. So, starting with, like we said before, find the problem that you want to go solve, and there's some specific guidance there because I've seen many organizations, both in the public sector and the private sector, go off and implement an AI approach and fail for one of two reasons. A, they went after the most critical problem in their organization, and when they developed the AI and it broke, because it will fail several times along the way, they crater the business or they cause real significant impact. Or the other approach is they take something so meaningless as because they're so risk averse that when they're successful, no one gives a damn. And so what I like to say is you got to find your Goldilocks. Find that application or that problem set that's important to the business, and that when you're successful, you can build on that success. People will value the return on what you've delivered. But if you do fail, and you will, there will be problems, there'll be hiccups. It's not like you've cratered the business or caused impact to your business operations. You can recover easily and fail forward. And so finding that sweet spot of an important but not mission critical, but also valued application is my first piece of advice. The second piece of advice is go off and do something. Get your hands dirty. Way too many companies spend too much time either planning to use AI or doing lab experiments that never see the light of day. And so one of the next piece of advice is build your AI, get your people involved, get the right stakeholders in the room, and then go try it. Get it out of the lab. Build into your plan the transition to practice so that it gets out of the lab, out of the developer's desktop or laptop, and into production. And again, that's why picking the sweet spot is important, because you want something that you can go into production and show your stakeholders and your business operators the return on investment and the value it can provide to them in a meaningful way. And that's important because if you never get out of the lab, and a lot of agencies and corporations are trying all sorts of AI things, but the executives are never seeing the value because it's never getting out of the lab. It's we did this cool demonstration, but it was trained on fake data, and I'm not running it against customer information. Well, that's a problem because then no one's ever seen the real value. They see potential, but are they going to invest in deploying it? So build into your plans the getting it into a trial. And then last piece is, and this is something you have to start from the beginning, is build in the visibility. Document and know where your data comes from, how it was labeled and used, what are the tuning and model optimizations that were done, and how are you going to secure it and attest it when it's deployed to maintain that security. One interesting piece of advice I've been giving people as they're looking at things like generative AI is your job from a security and a trust perspective doesn't stop when you deploy. You need to constantly monitor that AI, not just the security like you do from an Infosec perspective, but from a reliability perspective, make sure that it's still producing accurate results. And that means testing the model with both canned and new prompts and questions to make sure that it's still responding within the range and parameters, because most of these generative AIs learn from the prompts, learn from every interaction. And whether it be on purpose malicious or even just random testing, can skew the results, can get to those hallucinations that we've all heard about. And so constantly test and validate. And if you find that it's starting to drift, you can then, there are techniques to bring it back in line, whether you roll back the AI or you do some additional training in order to be able to get it back into the acceptable range of what the results should be. And so it's really about building that transparency and visibility and monitoring it. And this is a term we talk about, in Zero Trust and other regimes, continuous monitoring. It applies here to AI as well. We need to continuously monitor these systems to make sure they're still doing the value that we expect.
Continuous monitoring and improvement. Continuous monitoring and improvement. Continuous monitoring and improvement. We say that about everything in tech, right? I don't care if you're in security, you're in DevOps, applications, finance, business operations, logistics, legal, wherever. It's always about continuous monitoring and improvement. You want to improve on what you're doing. Don't assume that just because you built a model that it's good enough. Always identify other ways to really refine that data, refine the way that model operates. One thing I've actually, after our conversation, getting ready for this, is I went on a rabbit hole of research, right? Because you said a few things that really intrigued me, and it's exactly kind of one of the things that I see people really miss on. One, when people look at AI security, to think AI could be deployed in security. Now, AI is likely acting as an additional engine, but it's not all AI. Nothing is all AI at the moment in the cybersecurity realm. All the pioneers in the AI security realm now are not securing AI, but they're rather helping you identify how responsible your team is in training models of AI, specifically around IP, PII, PHI, and things that could potentially be construed as a breach by a regulator of you training potentially a public model or otherwise. So I just kind of a few clarifying things to our audience members here at the very end of the episode, Steve, but I think are very, people to understand, there's no 100% AI tool, and all AI security at the moment is not securing AI or helping you identify AI attacks, but they're rather helping you manage AI deployment in your environment, which you need, because you can't say no to AI in your organization as a security practitioner. If you say you can't use Chat GPT or you can't use any AI model, they're just going to go around you. They'll find a way to circumvent you, and you're going to be blind. So get a tool that helps you at least set some boundaries around using PII data or PHI data in your training models, by tokenizing it, by really hiding it, and kind of keeping it so that you can give your model the right data, right, and not give it synthetic data that may or may not do the end result you're looking for.
Exactly.
Just kind of as a general rule of thumb. Steve, best way for people to connect with you?
So the best way to find me is on LinkedIn. It's SORRIN, Soren on LinkedIn is the best way to find me. And look forward to connecting with you.
Yeah, I'll put that in the show notes. So for everyone listening, if you're listening right now, just scroll to the show notes. You'll see a LinkedIn there for Steve. And if you're watching us on YouTube, just scroll down to the notes there, and you'll see it there, as well as LinkedIn, Facebook, Instagram, Twitter, X, as I like to call it, and Twitch and everywhere else. Steve, thank you so much for being so generous with your time today and really dropping so many truth in this episode. I think this is going to be the must episode for must watch, much like listen to it, turn it into a playbook. We'll put that on Substack, by the way. A whole summary of this episode with all the takeaways will be on our Substack as well. So go check it out there. Steve, thank you so much for tuning in. Everyone, please make sure to share, subscribe, go follow Steve, check out his work, and maybe, bring him in to speak to help deliver this message to AI, or better yet, just for my selfish purposes, tell everyone to go subscribe to the podcast and listen to this episode. That also works for me, but not for Steve so much, but for me, it does. So with all that being said, Steve, thank you so much for coming in. Have a great summer, buddy. And I hope you get a little bit of relaxation before fall comes upon us. Something tells me third and fourth quarter are going to be crazy.
Yeah, thanks a lot, James. It's a pleasure being here, and I look forward to interacting with you in the future.
Absolutely. Thanks, everyone. Have a great rest of your day. Have a great weekend. And most importantly, stay cyber safe.
We love feedback, so make sure to connect with us on social media and subscribe to our podcast on your favorite podcast listening platform.